This is George Blake, W6BDD again. Another update on the Collins. We are very close. So, spoiler alert, I've already checked the low voltage AC out. I call it low voltage. All of the 120 volt AC circuits are operational at the moment. So, I'll show you what the front looks like now. So that's AC on. As you can see, my little 6-volt LED T1 3/4 base replacement is working. It's a nice whitish color. I could change it to yellow, more of a yellow, softer color, but nah. So the meter light works, got all the knobs back on. There's my AC indicator. And I got my relay control. Right now I got my Johnson 13 volt power supply turned on, so I can actuate the relay, the transmit relay. So that controls one relay that I put in. It's inside the chassis, which controls the main AC relay. Here's my high voltage. As you can see, I got rid of the resistor with the lead going to the high voltage doorknob. And the main reason I did that was resistor leads are not meant to be used as supports. So after being bent back and forth probably a lot of times, it finally snapped off. And I was going to redo it anyway, so I moved the resistor over. I got these nice ceramic capacitors, not capacitors, ceramic high voltage caps for the 811As, and hooked that to the doorknob. Put a enameled wire jumper in place of the solid bare one that was there. So I've got the nice protective ceramic caps now here. And let's see, let's go through what else did I do. The bias voltage. Yeah, that was the part I was really concerned about. The bias voltage says on the schematic minus 170. Yeah, no, it was minus 193. DC average. Okay, so let me emphasize that. Average DC voltage was 193. It should be about 100 volts. No more than 100 volts negative. So, and I have the gas discharge tubes in on the filament lines and on the grid and on the output. And it was firing on the grid. Well, the reason is that take the 193, multiply it by 1.4, you get 225. So that's your peak average, it's your peak voltage. And the gas discharge tubes are 200 volt gas discharge tubes. So yeah, there's a good possibility with little line spikes and stuff that it's going to pop. So I wasn't going to change the gas discharge tubes. I went for a nice little resistor stack right there. Two 25 watt 5K resistors in parallel makes 2.5K. And that's enough to drop that grid down without affecting it. It's about 16 milliamps. But I didn't have any place anywhere else to mount it. And actually being mounted right there is good because it's next to the fan. So if those resistors do get hot at all, they will dissipate from the fan flow. The fan is running right now. It's nice and quiet. I oiled it up really well. The tube sockets are ready for the new tubes. I cleaned up the switch in the back, the wafer switch. Got that all contacting properly. I have not tuned the coils yet, so I have as of yet to do that. That's the next step. But high voltage is all in. Right now the high voltage line is capped. Let me shut this off. I made a little handy interface cable for the transmit relay. If you haven't followed what I was going to do with the AC, shut off the AC here for a second. There we go. So the solid state relays are set up so that if one of the two lines or one of the two fuses fails in a 240 volt system, you've got the two lines coming in, hopefully through the two fuses, which Collins didn't do. I've rectified that problem. We'll simulate a failure. So we'll take one fuse out. I do this one-handed here, maybe. Hold on. There. Okay. So I've got one fuse out. So if I turn on the AC line now, AC is on. I will turn on the switch. There's no AC. Oh, why is that? Because what I did was the solid state relays are AC line controlled. So if you will, there's a circuit A and a circuit B through the normal Collins system, which I've kept. So I've got circuit A's AC coming in and is going through the switch, AC switch, to the circuit B side solid state relay. And I did the same thing with the B side. I take the AC out of the switch and go to the A side control. So what I've done is I've cross-circuited the A and B to control the opposites solid state relay. So if you lose phase or power or the fuse on circuit A, it'll kill circuit B, which means that there's now no power to turn on the A solid state relay, and vice versa. So by doing this, I prevent, hold on, put this back in. There we go, locked in. So by doing this, I have stopped, if you will, the AC being on. If one circuit's gone, the other circuit before in the Collins system still had AC to it. That was in a with the cross. Well, they tied the fuses together with the 120 system, and they ran separate lines on a 240 system because there's two separate primary windings. They're both 120s. So if you remember from your electrical days or not, two windings in parallel are used for 120, and two windings in series are used for 240, with the center between the two of them as a neutral. So what I've done is I've run the AC, whether it's 120 or 240, through the fuses first, then into the solid state relay circuit, which demands the one line, or actually both lines, to be on and the switch turned on. That energizes the two solid states. That then goes down through the soft start, because of the current draw when this thing starts up. I have not completely tested this out yet because the high voltage is still capped off. So once I solder in the two wires and attempt a high voltage test, then we'll see what goes. But as of right now, all the AC works, and when it's not supposed to work, it doesn't work. And I got the filament voltage, I got all the grids, I got my GDTs in, got my resistance dropped down. The grid voltage when I power up is still a little bit high. Let me just demonstrate here. Let's see, turn this on. There we go. So without the relay kicked in, right now I've got 92 volts, negative. So that's good. That's good cutoff voltage for the tubes. So now when I key on the transmit like that, it pulls a relay in. This is now negative 3.5. That's okay. I prefer it to be negative 4. So right now I've got a 47 ohm resistor in to ground through the transmit relay. So I'm going to drop that down a little bit. Going to draw a little more current, but that's okay. It's only on. It only does that when you key on the transmit. So when you turn the transmit off, of course, it goes back up to or down to minus 90. So that part is pretty well worked out. So I got bells, lights, and whistles of sorts. Transmit, AC, fan, filament, grid. So the next step is tune up the bandpass filters, because I did rewind 2 of the coils that were burned, and then hook up the high voltage and see what happens, and then it'll be time to put it on the bench and rock and roll. So thank you for watching. Thank you for subscribing. I appreciate that, although I don't get paid, but that's okay. I prefer to help the ham community and help anybody to learn electronics. So at this point, that's where we're at. That's about all I got. So next update should be fairly soon, I hope. We'll catch you soon. 73s, W6BDD, I'm clear.